happen if we mix potassium chlorate with the zinc powder? Let's find out. In this experiment, we'll use potassium chlorate, zinc dust, 18 molar sulfuric acid, a ceramic crucible stand, a blast shield, and a flame retentive blanket. Begin by measuring out 2 grams of potassium chlorate. Next, measure out 2 grams of zinc powder. Since this mixture is sensitive to shock, use your scapula to gently mix them together. You can pour them back and forth. This is just called the diaper method. But you don't want to put pressure on it. Certainly don't use a mortar pestle, but just pour them back and forth until you have a nice even mixture. And finally, add your mixture to a ceramic crucible. Now we're going to add just a drop of 18 molar sulfuric acid. Check out what happens. And here you can see some of our products. We have some zinc sulfate and some potassium chloride. Here's the balanced equation for this amazing single displacement redox reaction. We begin with the reactants zinc, potassium chlorate, and sulfuric acid. We have 4 moles of zinc, that's 4Zn. We have 1 mole of potassium chlorate, that's the KClO3. We have 4 moles of sulfuric acid, that's the 4H2SO4. When those combine, we get the products zinc sulfate, potassium chloride, and water in the form of vapor. We have 4 moles of zinc sulfate, that's the 4ZnSO4. We have 1 mole of potassium chloride, that's the KCl, and we have 4 moles of water, that's the 4H2O. This is a reduction oxidation reaction. As zinc is losing electrons, it's oxidized, and chlorine in the potassium chlorate is being reduced as it gains electrons in this terrific reaction. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.